All right, so very good, you guys. So Dustin, you changed yours. Excellent. Shauna, Ashley, Donnell is now typing A, B, C, D, E, F, G. Donnell. Okay, so you guys, let's look at the pattern, right? You know it? All right. Well, you guys are ready. We're waiting for Janae. In the what? In the notepad? Okay. All right. So yeah, so why Janae is writing the pattern. All you guys said that it is not linear. Tashana, what do you think? Okay. So why is it not linear? Go ahead, Kina. Awesome. Exactly right. The pattern does not go up by a constant number. We saw that on that one, huh? Yeah. So, what did you say? Janae, four, close, close. You're really close. It's four, and then you're just one off. It should be 4, 10. So if you guys look at the pattern, each step goes up by 1. So that's good. It goes 1 to 2 to 3 to 4. But then look at our pattern. So if we go from 1 to 3, we went up 2 times. Well, how much does it go up from 1 to 3? Yeah, so you probably were just looking at 3 to 6. Is where you got that? But 1 to 3 goes up by 2. 3 to 6 goes up by 3. So how many would we need to go up to get to the next number? So we started with 2, then we went to 3, and then 4. So, and then the next one would probably be, how many would we go up after 4? 5. Good, Donna, good. Okay, so that is our pattern, you guys. So it is not a linear function because a linear function means it has to go up by the same amount every single time. So good job, you guys. All right. Yes, you did. I'm very happy, very proud of you. That's good. All right, we're going to the next page. Okay. So we already went through a couple of these things with you guys, but as you know, like we said, quarter one is coming and you don't want to get zeros. So make sure you get all the way through the unit 1 test. That's in week 6. So there's a mid-unit test in week 4, and then there's the final test in week 6. So you guys do what you can. And the nice thing is that week 6 really doesn't have that much information, and week 4 doesn't either, just because those are test weeks. So those should be really fast to get through. So you guys can do it. Just work hard. If you make progress every day, you'll be able to do it. You can check your current grades in Infinite Campus. Just know that if you stop doing work, your current grade goes down. Then you'll be sad. Okay, so you have to keep doing work to keep your grade where it is. If you stop doing work, then your grade goes down because then there's zeros in your grade. Oh, I think sometimes they might not see it or something, is what I'm thinking, yeah. I mean, usually, maybe just send her a message and tell her, check these assignments, and then I bet, yeah, just double check that, because I can see them. I think they can see them. But just double check, send her a message. So anyway, you guys, so make daily progress, and we talked about parent-teacher conferences and pictures. All right, so let's go on to our objectives for today. We just have a few slides. We are going to identify the variables of a function and interpret their graphs. And then we're also going to find slope from some various representations. And that's all the stuff you guys are going to see in this week too. Okay, so it'll be, you get like 2 doses of it. Okay guys, we have some multiple choice, so get ready with your notepads. So we have a little graph, right? We're going to interpret the graph. And this is a trip by a car. So a car has made this trip. Okay, and we're going to answer these questions. But first what we want to do is figure out what are the variables. So who knows what the variables are? What's that mean? Those would normally be variables, good letters. But what we're looking for is like words. Think of, very good. Hours and miles. That's what we should move that from. So hours and miles. Very good, you guys. So our variables are And I'm going to do a little highlighting here for you guys. Hours is one of them, right there, and miles is the other. Those are our variables. Okay, so anytime you see a problem like this, hours represents X, right? We'll do an orange here. So hours is our X, which is our independent variable. And you guys think about independent. Donnell, you want to be independent, right? What does it mean to be independent? Exactly. Hours goes by itself, right? Can you ever control how many hours goes by at a time? Canoe. You cannot control time. So hours is our independent variable, and miles is our dependent variable, which means that depending upon how many hours go by, the miles that we drive changes. So those are our variables. All right, you guys. So you have to put multiple choice, A through G, in your notepad. Are you all ready? Okay, first question. What is the car doing from A to B? And you have to pick either A through G. Pick one. So put your, Janae, write in your notepad, put your letter. What letter do you think? A, B, C, D, E, F, or G? Question? What is the car doing from A to B? So see the red line on the graph from A to B? What is the car doing right there? See down below where your choices are? A through G? Okay, you guys have to pick one and then type it in your notepad. Your choice. You must pick a choice. Gotta pick some choice. Okay, and you guys make sure to pick your own choice because Kian. Ah, that is a good question. Uphill. Yeah. Yeah, that's a good question. Kiana just asked a very good question, and we will talk about it once you guys put in your first answer. I don't know. You guys got put in an answer. Okay, so Dustin has put in an answer. Oh, good. Kiana has put in an answer. You just want to put in an answer into your notepad from A to G. Which of those choices gives you the answer to the first question? What is the car doing from A to B? Okay, so I want everybody to put something in there. So Kiona's done. Donnell, you got to pick a choice. Where did you put? Oh, so what letter is that? Okay, so put B down there, just so I know. And then Ashley, what do you pick? Okay, so put all those. You can put multiple ones if you're not sure. And Shoshana, what do you think? Okay, type that in there. All right. So, you guys, what is the car doing from A to B? So, a lot of you guys said accelerating. And then some people said it could be potentially A, which is driving uphill. Okay. Now, you guys, here's the thing. Here's the tricky part. I see why you guys are talking about the uphill part because the line goes up, right? But here's where the variables are really, really important. Well, so here's the thing, you guys. We are comparing miles with hours, right? So as time goes by, what does this line mean from A to B? Are we increasing in our miles? So it doesn't mean we're increasing in elevation though, right? It means we're increasing in our miles. So even though the slope, because Janae, you're talking about slope, even though the slope is going up, that doesn't mean we're going uphill, right? Because that doesn't represent how steep something is as far as the hill. It just represents how many miles. So we are, as hours go by, like after 5 hours, how many miles have we driven? Yeah, maybe, I think each of those go by 10. So 60 miles, good. Now look, you guys, let's just look at this from B to C really quick. How much time goes by between B and C? 5 hours. And how many miles, though, have we driven between B and C? Exactly. We stayed at 60 and we've driven 0 miles. Good job.
Give you the 2-minute warning all night for fifth graders who need to be off here.
Okay.
2 minutes.
All right, you guys. So per hour. So from D to E, no matter which 2 points we pick, we'll have the same miles per hour. Same thing from C to D. The only thing is that from B to C, the car is actually staying at a constant. We'll do next, which will help us a lot with these problems. All right, you guys. So let's move on. So how do you find slope? You guys know how to find slope? Good job. Good job, Dustin. So we have M. M is our slope. And just like Dustin said here, it is rise over run. Good. It is a constant rate of change with a linear function. Okay, so here's the key for you guys in this week. You guys all know this equation, y2 minus y1 over x2 minus x1? Rise over run. Good. So subtract your y's, put that on the top. Subtract your x's, put that on the bottom. Good. All right. So if we look at this problem here, what's our slope? This is a 40 feet going up and then 100 on the bottom. So remember rise, our rise is 40 and our run is 100, right? So if we simplify that, we get 4 over 10. Where are you getting 60 from? Oh yeah, but you don't know your y coordinates. All you know, you actually, in this case, they have it easier because your rise is given to you and your run is given to you. So then we can reduce it again and get 2/5. 2 goes into 4 2 times and into 10 5. So for every 2 feet we go up, we go 5 feet over. Make sense?
Yeah.
Okay. All right, you guys, what we're going to do then is we're going to actually look at 3 different representations today. Okay, and then that's what you'll do this week. So if you have a graph, do you see how we have our rise here and our run here? So you can pick any 2 points. So like I could pick another point even down here, and I could find my rise, and I could find my run. And over here on the right shows you how they found it between 2 points, but we're just going to count. So on this one, we have a rise of 1, right, and a run of 2. And on the second one, we have a rise of 2, but a run of 1, 2, 3, 4. So the reality is, though, is that the same slope? Yes, because our slope on the first 2 points was 1 over 2, right? Our slope on the second 2 points was 2 over 4, but what does that reduce to? 1/2. So the reality is if you have a line that's a constant rate of change, then it doesn't really matter which 2 points you pick, it will always reduce to the same slope. Make sense? Good? Okay. All right, so another way you can see slope is by doing a table. So in this case, if we want to find the slope of a table, what you guys have always done before, like if you look at this example on the right, is you've always figured out the change in the y, right? In the past, though, you guys have said, well, then that would mean the slope was -4. But now we also have to pay attention to the change on the left. So to figure out slope from a table, we still do rise over run. So in this first table, our rise between any 2 points, and again, it doesn't matter which 2 points, is -4. What's our run? -6, right? Always look at the change. Between 9 and 3 is -6. We can reduce this to 2 over 3, right? Negative divided by negative is a positive, and 2 goes into both. Okay, so look at this one, you guys. Pick a choice. What do you think our slope is for this one? Well, it has to be A, B, C, D, or E, or F. Are you choosing B, Dustin? You're thinking B? Janae, what are you thinking? Which letter? You're choosing A? A and F? Okay, you guys, so choose one. You guys can only get one. You only get one choice on this one. Okay, E. Okay, so we got an E. Dustin, what's your final choice then? So we got an E and a D. You guys ready for this? What's the change in Y? Good. 5. What's the change in X? Ah, and remember what slope is? What over what? What's our rise? What's our run? Ah, yay. So it's C, you guys. You were close. You were close. It's C. C is our correct answer. Yay. Justin, you were just reversed, I think. So you were, good job. So just be careful, keep rise over run. All right, you guys. Almost the last representation. So on this one, it says, what is the slope of this function? I just want to make sure you guys can do this with points too, okay? So these points are the same thing you saw on the table. You know how to do it with points? So how do you do it? Oh, I'm going to have you do a choice. So think of a choice, Dustin, and then Janae, while Dustin's thinking of a choice, if you look on the right, these 2 points that I'm giving are the same points that would be on a graph, right? So we would still do rise over run, so we would take one of our points, y's, and subtract the other y from it on top. That's that y2 minus y1, and then we would look at the x coordinate, and we would subtract x2 minus x1 on the bottom to get our slope. So same thing that we did in a table. In fact, if I were to draw a table for you, right here, we have our x's on this side and our y's on this side. I could have my x1 here and my y1 here, my x2 here and my y2 here. And I'm doing the same thing. I'm going to figure out the change here and put it over the change there. So this is my rise on the right, and this is my run on the left. Oh, the numbers are here, 4, 3, and then -2, -1. So yeah, see if you can figure that out. Subtract. So this little equation here, that m equals, we want to subtract. Dustin, what'd you get? Did you get one?
Mm-hmm.
F and B. Let's see, F and B. So actually, it's just which one goes on top. What do you think?
B.
I'm going to say B. Okay, so we've got a, this one's U. The little dot there. Oh. Is that one the one you think?
Yeah.
Okay. Well, do you see a choice that would make that be the right answer? Or are you taking your computer? You just trying to get in. Janae, do you want me to go over it? Okay. All right, you guys. So we have y2 minus y1. So it doesn't matter which points that you pick, right? I could have this one be my x1 and this one be my y1. It doesn't matter. I could have this one be my x2 and this one be my y2. But I could flip it. It doesn't matter. So if I follow the equation over here on the right, I would take -1 minus 3. That would be my change in my y's, right? Have to pull my y values. And then my x's would be -2 minus 4. So anytime you have a double negative, you can turn that into a positive and make that be a negative. So you'd have negative, oh, -1 plus a -3. Or are you talking about the 4 on the bottom? Oh, and the 4 on the bottom comes from here, right there. So those are my x's. So -2 minus 4, again, make that a positive, turn that into a negative, and I get -6. But then I can reduce. What's a negative divided by negative? Positive. Positive. And then what goes into both 4 and 6? 2. Very good. 2 goes into 4 2 times, into 6 3 times. So, Justin, your answer, you correctly chose the right one. Congratulations. Very nice. Very good. All right, you guys, we're about ready to be done here. I think this is our last slide. Okay, this is rate of change, and the reason I bring this up is because I want you guys to know that rate of change is still just slope. Okay, so this is slope. It's not any different than slope. It's just that it's usually in a word problem, some kind of contextual scenario. So in this problem, it says that you're a waiter, and you notice that after you made $40 after 2 hours, and you made 100 or 220 after 5 hours. So you guys, in order to find slope, you always need 2 sets of points. So I'm going to go ahead and put the 40 and a 2 as a coordinate point. So what would I put first, the 2 hours or the $40? 2. Good job, Fiona, good job. Because remember, hours is usually our x. So anytime anything independent becomes our x. So we've got this point. Then we also have the 5 220 as our second point. And now we can just do what we did last time. We can make whichever one we want to be our x1 and whichever one we want to be our x2. So I'm going to call this one my x1, y1, and this one my x2, y2. So let's do our equation. And we get 220 minus 40 over 5 minus 2. That's a 2. You know, it looks kind of like it was about to be a 3. But, you know, I quickly corrected. Don't want to mess that one up. So what is that? 60. Good job. Okay, now you guys, when we do rate of change, because we have a problem, we can't just leave our answer as 60. So what is that? 60 what? Yes. Good. $60 per what? Per hour. Nice job. Nice job. Because our variables on this, X means our hours, and Y means dollars. Good job. So whenever you do rate of change, just make sure you divide it so it makes sense. Even if it doesn't come out even, do it in your calculator. And the number you get is going to be the Y over the X. All right, you guys. So here's what we learned today. We are finished. And hopefully you guys are all going to be good with identifying variables of functions, interpreting the graphs, and then finding slope from various representations. And that concludes our webinar for today. Any questions? You guys are good? All right. Excellent.